Audio mode. Let's turn that off. That's not really very helpful. And then, assuming that there can be a chat, I kind of want to get the chat going. Oh, I should have started recording. Well, yeah, I'll just go ahead and start recording now. Those of you watching this not on Sunday, December 1st, hi, my name is Savani. I went through an entire introduction before I hit the record button. I have no idea right now whether Twitch is going to actually record the entire stream. So I'm recording locally in addition to streaming at the same time. And I need to spend a couple of minutes right here mucking about with my stream setup because everybody has chat on their stream. I kind of want to have that too, and I've had that in the past. So Twitch stream or Twitch chat on OBS. There we go. How to add. Did I use CapChat in the past? Maybe. Or maybe it was Streamlabs. I don't remember which I used. Let's see here, CapChat. I won't set that up tonight. So assuming there is any chat, I'll try to read out the chat. But yeah, we're just gonna get started. And maybe tomorrow night I will have the stream chat working. So my terminals actually crashed just as I was starting the stream. So let's bring some back up. There we go. Looks like that's going to be really tiny, so we'll zoom it in. That's looking pretty good. Bring it over here. I've already done a little bit of setup. I usually do Advent of Code in Rust. I've been doing it that way for a long time. I like doing stuff in Rust. It's a great language. I get to do it professionally, which is kind of amazing. And the setup that I usually have, I'll just quickly show it to you. I'll have a main function. So it ends up being an application, and then I'll have a separate component or a separate module for each day. And it's really quite dirt simple. So I would just do from one level higher up, I would do a cargo run 1A, or maybe it's dash 1A. I have to remember all of this each year. Yeah, that's about right. I haven't actually implemented anything yet, so of course it's going to be wrong. But it's just a great big match statement to go off and work on a function. But I actually do a lot of this work in a very test-first development mode. Want to get as close as I can to the right answer before I feed the real data in. So let's just get started here. Advent of Code 2024. Gonna jump in here. I have not logged in yet. Let me bring it over here so I can do the login without potentially revealing anything. Yeah, that's what I thought. Use a good old passkey here. Sign in. There we go. Authorize. And we are good. So, day one, cup of tea. So let's see here. Historian hysteria. The chief historian is always present for the big Christmas sleigh launch, but nobody has seen him in months. Last anyone heard, he was visiting locations that are historically significant to the North Pole. A group of senior historians has asked you to accompany them as they check the places they think he was most likely to visit. As each location is checked, they will mark it off their list with a star. They figure the chief historian must be in one of the first 50 places they'll look, so in order to save Christmas, you'll need to get them 50 stars on their list before Santa takes off on December 25th. I'm not going to save Christmas. At least, I don't think I am. I'm going to try, but don't bet on it. Collect stars by solving puzzles. Each puzzle grants 1 star. So I haven't even left, and the group of elvish senior historians has already hit a problem. The list of locations to check is currently empty. That's gonna make checking really hard. Eventually, someone decides that the best place to look, or the best place to check first, would be the chief historian's office. Upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. Instead, the elves discover an assortment of notes and lists of historically significant locations. This seems to be the planning the chief historian was doing before he left. Perhaps these notes can be used to determine which locations to search. Throughout the office, the historically significant locations are listed not by name but by a unique number, the location ID. To make sure they didn't miss anything, the historians split into 2 groups, each searching the office and trying to create their own complete list of location IDs. Just one problem. Hold the 2 lists side by side, which that's what this is going to be. 2 lists side by side, location IDs. Quickly becomes clear that the lists aren't very similar. Maybe you can help the historians reconcile their lists. So, for example, we've got these 2. So maybe the lists are only off by a small amount. To find out, pair up the numbers and measure how far apart they are. That's interesting. Pair up the smallest number in the left list with the smallest number in the right list, then the second smallest left number with the second smallest right number, and so on. Figure out within each pair how far apart the 2 numbers are. Need to add up all of those distances. Okay. So we pair 3 from the left list with 7 from the right list. There's no 7 in this right list. So I guess this is just an example here. But the distance apart is 4. If you pair up a 9 with a 3, the distance apart is 6. Cool. So the pairs and distances would be as follows. So this is really all of our test data, and this is what we're going to start out with. I'm going to quickly look at the puzzle input, and it looks just like this. That is a lot of numbers, as always. So let's get started here. Very first thing I always do, const input is a string equals include stir data slash day1.txt. When I'm doing advent of code, I do not ever try to like load data. I just compile it directly in using the include string macro. Poorly, apparently. Cool. So the day is not yet found. We're just going to copy everything in. There's 1,000 lines. There's spaces in between each pair of numbers. And now what I'm going to do is I'm going to grab the test data here and hard code this into my test module. Does this work? Yes, it does. I forget what the rules that Rust has for a multi-line string. I would love to be able to indent things over, but I don't want that to mess things up. And now I don't really know what I'm doing next. So let's do some more reading here. So the smallest number on the left list is 1, and the smallest number on the right list is 3. So I can start out just by figuring out the smallest numbers. So we want to let lists equals parse lists test input, and let's quickly define parse lists now. Now, what do we want to do here? I think what I want to do is just return two separate lists, or make it really simple. I don't know whether the numbers can be negative, so I'll make them a couple of I32s. Actually, we can see whether the numbers are going to be negative. I see no negative numbers in here, so let's take that out, because there are potential math complications around 0 if there are negative numbers involved. And for the moment, I'm just going to return two empty vecs. So left list and right list. So we're going to assert EQ. Smallest of left list is going to be 1. And assert EQ that the smallest of right list is going to be 3. And that right there is a test that we can just start with. What is angry? Oh, that's what's angry. Okay. That's the issue there. Cool. Everything should compile. So cargo next test. Actually, I want to do cargo watch -x next test. And of course, that test fails because, I mean, left list and right list are going to be empty, plus the smallest value is going to be 0, which is wrong in both cases. So let's get this working. Overall, pretty simple. We are much too early to start bringing in a complex parser. So let's take input.lines. Let's see, for each line, we want to split the line into two numbers, and each number needs to be inserted into a list. So let mute left list equals an empty vec, same with the right list. And we're just going to return those. And then, so we get lines. And for each line, we have some text. So let split operator, Rust string split. It is literally just the function split. Returns an iterator over the substrings, matched by a pattern. Okay. Okay. Pretty easy then. Let values equals, well, yeah. Text.split. We're going to match on a white space. Then I want to, I'm not sure exactly what this is going to give me. It might give me, yeah, it's going to give me some empty spaces. So I'm going to also filter those out. Then I want to collect. And if that's right, let's go ahead and print it just to make sure. Not quite there yet. Collection cannot be built from, okay. So I need to clone each thing. Yeah, that doesn't work. I don't think this works either. I think I'm cloning too early. Yeah, I'm still getting an iterator over some string references. So let's see here, text split filter. And then over each one of these. So we split it. We get a list of string references. We filter out all of the empty ones. For the ones that remain, we're going to clone them, and then we're going to collect them into a list, which is a lot of things to do at once, and I'm still not getting it right. Oh, clone isn't the right thing to do. You go from a reference to a string to an actual string by calling toOwned. And what I expect to get, okay, cool. I'm really curious as to whether the split function will give me some empty strings, so I'm going to remove that filter for a moment. Oh yeah, quite a few empty strings. So let's go ahead and filter those out. And then because I just haven't done enough in a single line, I'm going to convert each one of those into a number. So let's see here. I do this very rarely. I think it's t.parse u32. And I'm just going to throw away any errors because there shouldn't be any. That's one of the things about Advent of Code. You just don't get bad data. It's one of those things that they guarantee. Okay, that does work. So now we're dealing with numbers instead of just instead of a bunch of strings of numbers. So each one of them, yeah, I'm going to left list dot push values 0, and then right list dot push values 1. And so this should give me, I need to enhance this test a little bit. There's not quite enough here. First of all, Left list should be 1, 2, 3, 4, 5, 6 elements. Same with the right list. And then left list should be a vec of 3, 4, 2, 1, 3, 3. I'm going to do a similar test for right list. I'm just being super pedantic. 4, 3, 5, 3, 9, 3. Close it. Okay, test is still failing, but it is failing on line 49. So right here, the first call to smallest. So clearly, all of the rest of these already passed. So, and also clearly smallest is going to fail because 0 is not the right answer. Since we are just dealing with numbers, the way I'm going to handle this is I'm going to sort the list. Yeah. I don't actually know that smallest is going to be valuable in the future. In fact, I already know that smallest isn't going to be a valuable function. Ow. I have a dog chewing on my toes. That's fun. Yes, come here. Come here. Come here. Gotcha. Here we go. Meet the little toe biter. Mm-hmm. Mm-hmm. Because it's a little bit dark in my office, I'm going to turn on some extra light here. Ah, much better. Okay. So the way that... yeah, no. I'm just going to get rid of smallest. Instead, what I want to do is instead of calling smallest, I want to assert that the first element of each list is the, in this case, what I know to be the smallest value. So first element of left list should be 1. The first element of right list should be 3. And I'm doing this because I know that from the problem, I want to find the smallest one and then the next smallest one and so forth. So basically I need to get a sorted list. So I'm going to parse, or I'm going to sort each list, which should be, or maybe I just return the sorted. I don't know for sure that I will always want to have the sorted lists. So I'm going to, I'll keep it as the 2 lists get parsed and returned, and then I'm going to sort a list. And I want to sort it in ascending order, so input, yep, we're going to consume the list and return a new one. Rust list sort. I think here we go. Sort. Sorts the slice, preserving the initial order of equal elements, which totally okay. The implementation does not implement a total order, which is fine. I mean, that's basically a way of that's useful if elements that have the same value can be distinguished in some way. These are numbers. A 3 is a 3, and like it doesn't matter which 3 I'm getting. So it's going to just sort in ascending order. So v.sort, sort eq, cool. I need to take input as mutable. So input.sort, and then I'm going to return input. And then tests should still be failing. Yep, good. Now, okay, there we go. So sorting each of the lists, the first element of each list is, or the first element of the 2 lists is the smallest. So distance between them is 2. So that's really just like right side minus left side absolute value, or absolute value of left side minus right side. It doesn't matter. Second smallest is 2. Third smallest is 3. Okay, so the rest of this is just getting all of the pairs and figuring out the differences between them. So I'm going to write a function to pair the lists. Or really, this is zipping the lists. Left is a vec u32. I'm going to consume both of them again. I'm going to return let's see, is there a zip function? I think there is. That might be in the iterators. Rust zip. It's in std iter. Okay. And we'll write a test for this. I'm going to grab this code, parsing the lists, sorting them, and now we're going to check the first few values. So zipped bracket 0 should be 1 and 3. So 1 and 3, and then the second smallest should be 2 and 3. And then okay, third is going to be 3 and 3, or no? Yes, 3 and 3. Then 3 and 4. And then the last, no, not quite the last one. We're going to do 3 and 5. And then 4 and 9. Okay, so vec u32 is not an iterator. That makes sense. So we'll turn it into an iterator. Does right need to be an iterator? Nope. And the test passes. So that's cool. We're good. Yeah, okay. And then we're going to do a difference between the two pairs. So left U32, right U32. This is really quite dirt simple. So we're going to do left minus right dot ABS. No method found in U32. Oh, okay. I'm going to switch to I32s, even though originally I said there might be a complication around 0. Since I know that we're not going to cross 0, I don't care. And I don't want to deal with integer type drift. It's kind of a pain. Cool. Okay, so that passes. We're going to do a basic test. I'm not actually going to test all of them. I'm just going to test the first, like, 2. So we got the zipped one, so assert EQ. Pair diff? Yeah. Okay, the zipped value is 0, and the difference should be, or the distance should be 2. In fact, let's name it that. The next one, the distance should be 1. And the test pass. So what we need to do, the solution that we need, is the total difference between the two lists. We should get a total of 11. So pairs dot into iter dot I want to fold. No, first I want to map. No, folding is fine. Initial value of 0, and then, ooh, I have forgotten the parameters for fold. First one is the accumulator. The second one is the current value. So it's going to be left, right. I don't care. I can just say a pair, because we're going to say ACC plus distance pair. And then all of that should add up to 11. And we'll just do it right here. Total distance. And if that works, okay, cool. So that works. So now we're going to run it on the real input. And the way we do that is basically we're going to take all of this code that we just wrote right here. I'm going to paste it into day 1. Jump it back, let zipped equals is that, and then total distance of zipped, and I'm going to format it. And I don't want to use test input here. I want to use the real input. And now we're going to cargo run 1A. And here's our answer, 100 and, well, it's a big number. And all we have to do here, paste it right in here, submit, and cool, 1 gold star. Now we move on to part 2, which part 2 will always build on part 1. Here we go. Analysis only confirmed what everyone feared. The 2 lists of locations are indeed very different. Or are they? The historians can't agree on which group made the mistakes or how to read most of the chief's handwriting. But in the commotion, you notice an interesting detail. A lot of the location IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but were rather misinterpreted handwriting. So this time, need to figure out exactly how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times that number appears in the right list. Okay, so the 3 is right here in the left list, and it appears 1, 2, 3 times in the right list. So it'd be 3 times 3 is 9. And then the 4 here only appears once in the right list. So that's a 1. So 9 and 4 is 13. So 9, 4. Okay, that's not bad. So the 5th number is a 3. So these can appear more than once. I could be really clever about it by like figuring out that a number appears a certain number of times in the left side and only calculating this once, but I'm not going to. We're not dealing with a data set nearly large enough for that to be a problem. Oh, actually, I kind of do want to be clever here. Yeah, I'm going to be super clever here. Because hash maps are amazing. So use collections hash map. And what I want to do, there's a technical term for this. I'll just call it a frequency count. So type frequency count equals hash map. The key is this number, so that's an I32, and then the count is actually a U32. We'll just make that simple. Technically it's a U size, but we won't deal with that because the math can start getting a little odd. I'm going to keep it with I32. Okay, so now, we're going to take a frequency count on a list. So let CNT equals hash map new. We're going to return it. So that's going to force the data type to I32, I32. And now we're going to consume the entire list. And as we do, each time we find a number, we're going to, for each number, we're going to find its entry in this count list. And we're going to increment the count. So actually, let's do it this way so that it's clearer, and then I'll rewrite it into an iterator expression. So let's see here. For number in list. So CNT dot Ooh, this is a pretty common operation, but I've forgotten it. I haven't done it in a long time. Oh, wait, no, I do remember. I'll go ahead and bring the documentation up, but this is one of those things that's very easy in most languages, but the Rust borrow checker makes it a little bit harder here, and that's like checking a value or even getting a value out of a hash map and then modifying it, because like wait, why is that hard? Huh. Yeah, I've kind of lost track of why that's difficult. I always run afoul of a problem with the borrow checker there due to the number of things that, or due to the number of related things that have to be borrowed mutably. So instead I use the entry function to try to get the entry. So cnt.entry, yeah, so the key is going to be number. And then if the entry is present, we want to call and modify, I think. Yes, and modify. So we get an entry back. We call so cnt.entry returns an entry, and the entry might exist or it might not. If we call and modify on this thing that might exist or might not, this and modify function will only occur on an entry that does exist. So we'll say E, and in this case, they're doing almost the same thing we're doing. So E should be, yep, a mutable point or a mutable reference to an I32. And we're not returning anything, so we'll do that. If it doesn't exist, then we're going to insert a value to begin with. And in this case, we're just going to insert 1 because this is the first time we're encountering it. So let me check that the frequency count is correct. So we got the frequencies, and then we assert EQ. So frequencies should be, yep, it's a hash map. So frequencies.get. Well, you know, we'll go through and do it exhaustively. So we'll start with 1, and that should occur once. And then we'll go to 2, which should also occur once. And then 3 occurs 3 times in the left list. We'll show it right here. So like here's the single occurrence of 1, single occurrence of 2, 3 occurrences of 3, and 1 occurrence of 4. And we need to borrow all of these. Try using asref to convert option integer to option. I'm not sure what it's telling me. So frequencies.get is going to return an oh. Okay. So the type of what comes back from frequencies.get is right here. It's going to be an option of a reference to an I32, and I'm comparing it to an option of an I32, and those two are not compatible. I think I can just do this though, borrow a reference to each number, and that works, and it gives me, there we go, it does count the frequencies correctly. Let's verify that it's really working by forcing it to fail. So it just failed. canceling. It counts frequencies, and it failed on line 128, which is this one that I just forced to fail. So we'll undo that. Cool. Now we're going to write the total similarity function. Don't want pairs. We just want left list and we're only going to write one test for this. Unless, of course, something goes wrong, in which case I'll write more tests in order to try to track down the problem. So we get the left list and the right list, and we calculate the total similarity of the two lists. And it should be, according to this, it should be 31. Okay, so now we need to calculate this. Let's return a 0 to make sure the test fails. Perfect. Okay, so the left frequency, frequency count left list. Do the same with right. Now, I want to, for every element in the left list, I want to try to find that element in the right list. So, we're going to say for key in left frequency dot, no. We're going to say key and count and left frequency dot into iter. May as well just go ahead and consume it. So this should be a reference to an i30. No, it's an i32 and also an i32. Okay, cool. So this will be like, oops. This will be the number that I'm calculating on and the number of times that it occurred in the left list. And then we want to get right occurrences equals right frequency dot get key. So if key is 3 and it occurs 3 times in the left list, we're going to ask for the number of times that it occurs in the right list. And this should return an option pointer. Okay. So how do I want to do this? Like ultimately we're going to unwrap it, or we're going to return 0 because we don't care to work with an option. 0 is an i32. We're expecting a reference to an i32. Can I do this? Cloned takes an option reference and returns. Okay, so it'll clone what's in there. Cool. Now, go ahead and grab our similarity score here, and then similarity plus equals count times right occurrences. Then we're going to return similarity. And failed to make it mutable. And this should give us 31. It did not. It gave us 10. Okay. Okay. I'm just going to get some debugging information in here. So the key, the count, occurrences, get some nice formatting in. So key count write occurrences. Show me what you got. So 1 times 0. Is that right? Okay, yeah. 1 does not occur in the right list, so that's a 0. 3 occurs 3 times. 4 occurs... Oh. That's what's going wrong. I'm multiplying the count. This was me being clever. Right. I need to multiply the key by the number of occurrences in the right list. And then there's a number of times that happens in the left list. So 3 here occurs 3 times in the right list. So that's 3 times 3, which gives me 9. And it occurs 3 times in the left list. So that's the 9 3 times. And that's what I'm getting wrong right here. So it's going to be key times count times write occurrences. There we go. That gives me 31. So let's see what it's like on the entire set. Oh. So we're going to run 1B now, and lots of printing. Got a final number here. Going to copy it. And there we go. So Advent of Code, day 1. That is finished. Day 2 doesn't become available for 2 more hours, but I'm going to be asleep by then. So there's really nothing else to cover in this one. I could... Well, let me go ahead and commit this code. Push that up. Cool. And as is so often the case, I will share a link to the repository. It's going to be the Advent of Code repository on my server. So if you wanted to read the solution yourself, you could. Not necessary. I don't think that I'm going to jump over into my other project at the moment because it's not quite to the point where I really want to be showing it off. So maybe later over this streaming time is when I'll show it off. So on that note, I'm actually going to stop the stream now and just say thank you for watching, and I'll see you again tomorrow night at 9 p.m. for day 2. So good night, everyone.